Better?
Nice.
Well done. I hope that I can speak later on because I'm already feeling not so good. Oh my goodness. I think it's not allowed to let so many people in here, right? Wasn't that a problem? I thought that was a problem that too many people would have be here. So sitting there or standing.
Andre will block the lines. He will do the firewall for us.
Oh, okay. Wow. Oh. I really wouldn't have expected to have so many people here for the talk. Interesting. Wow. Hopefully the notebook is not going to stand by at some point. I put it in presentation mode. I tried with that one before. Do you want to take over? Now it's more serious than before. Now it's more serious than before. I'm sorry, I don't like it. Staying here, waiting. Yeah, it's... Yes, I would say.
Everyone, please welcome Thomas Woerner, who will be talking about firewalling. He will give you some general overview and we'll be talking about future plans and ideas. And he will most likely need also some input from you.
Okay. Is it working? The mic is not working, right? Okay, whatever. Okay, hello, welcome. So, I'm a senior software engineer at Red Hat, and I'm working on firewalld. And at first, I would give you a short overview, So what we have right now, the features and the enhancement that we did since last DevCon, and future plans in the end. So at first, I would start with firewalld itself. So it's providing a central system service, or one system service to take care of the firewall, to manage it. It supports IPv4, IPv6, and EB tables for bridges. In the past, we didn't have that with system config firewall and so on in RHEL 6, for example. The changes are done in place. So the issues we had before with reloading services, for example, the IP table service, which destroyed or removed rules that have been added by other services or applications, this is not the case anymore, as long as you're not doing a restart or reload. But we have signals for that to inform applications and services, yeah, it was a reload or restart, so please update your rules. We have integration into Network Manager, which is taking care about zone management for firewalld. We have code in libvirt to inform it that there have been changes and to add rules to firewalld directly. There's system config printer for printer management, which now made it to Python 3, which resulted in a small issue because we didn't have Python 3 bindings, but it's solved right now. There is fail to ban, which is able to use firewalld if it's available. And there are the init scripts from network services, which is also making sure that an interface will be bound to a zone. But it has some limitation. It's not a service. It cannot react on changes. So it just says it once to firewalld. And if you stop firewalld, for example, with systemd and start it afterwards, it will not know about that anymore. Okay, next one. We have I would say, comfortable configuration because you can configure really a lot of things, and everything is done in XML. We have a separation of the runtime and permanent configuration. So permanent configuration is done in XML files. So if you're starting firewalld, it uses this configuration from the files and make it available in runtime, and holds it also for a permanent configuration interface we have internally. We have additionally, on top of that, a separation between built-in configuration files, which you will most likely get with your system or out of firewalld, and also a directory. This is etc firewalld, where you can put in your changes, or where they are done, saved automatically, or where you can add additional files. So the default and built-in files are located in userlib firewalld. And as soon as there is a change to a zone, to a service, to an ICMP type, or whatever, it will be copied over to etc firewalld, and the chain with the change you have done. So the next time you start firewalld or you restart, you will get your own file, or the changed file. It's overriding the built-ins. For management on the command line, we have two tools. One is firewall CMD, which is mostly used in the system and also in some services. And there is also a special one, it's firewall offline CMD, which is used to do changes when firewalld is not running. So it's able to write to files of firewalld. And it's, for example, used in the Anaconda installer because there is no firewalld at install time running. So it's using firewall offline CMD to do changes to the files. And with firewall offline CMD, you can also change, for example, the policies for PolicyCade. But I will talk about that later on a little bit. Then we have we have one GUI config tool, which is firewall config, which is available in most firewalld in most Fedora versions. Right now, it's not by default installed in Workstation, but you can easily install it. And there is also an applet. This is firewall applet. It gives you a simple method to change zone bindings for interfaces, for source addresses, and also for connections. So the next point is services. So we had services or some kind of services already in system config firewall before and in Lockheed. And in firewalld they have been extended. So you have port ranges in there with a protocol, or you can add port ranges in there for a protocol. You can have net filter helpers and a destination address for IPv4 and or IPv6. A service is used to simplify the opening of ports for services that need more than one port, for example, or need additionally a net filter helper or a special address. Right now we have nearly 70 built-in services. I think 20 more than before. And they are completely adaptable. So you can use firewall CMD, firewall offline CMD, or the dbus interface of firewalld to change them and adapt them. You can provide them with your own RPM file. There is a proposal for providing service files and zones files with your own package. And there is a proposal in Fedora packaging guidelines how to do that. So you can easily add new services that are not available, or you can change services. And to add or change services, you can use RPMs, command line, GUI, dbus, whatever you like. The next one is, here are some examples for services. For example, the DNS service, which is opening port 53 for protocols TCP and UDP. The second one is TFTP, which is using a contract helper. This is NF contract TFTP here with a UDP port of 69. The next one is HTTPS. Okay, this is really a simple one because only one port. So, but it simplifies because you don't need to have the port number. And DHCP-v6 client, which is used or which needs to be there and activated to be able to get an IPv6 address. With IPv4 DHCP, you don't need that because there was a special way to do DHCP4. It simply bypassed net filter. So it uses raw sockets. So there is no need to have a port open for IPv4 DHCP. But for IPv6, you need to have that one. If you don't enable this one or it's disabled, I'm sorry, you will not get an IPv6 DHCP address. So the next one is zones. In zones, you can add other features of firewalld, for example, the services. You can also add ports there and port ranges of protocols, or only protocols. Then rituals, which is something that came in for RHEL 7. You can add ICMP control, ICMP blocks to block, for example, ping, requests, replies, and so on. You can enable masquerading, and you can also add rules for port and packet forwarding. You can see a zone like a firewall configuration, a complete set of firewall rules for an interface or for a connection or for a source address. You can bind this to every one of those. Right now we have built-in zones. And additional to the old one, which are blocked, EMZ, drop, external, home, internal, public, and trusted, and work. We have two new ones since Fedora 21, which is Fedora Server for the server product, and Fedora Workstation for the workstation product. You can adapt all these zones according to your needs. So firewalld is providing the built-in zones, and you can customize them according to your needs. So if you don't need if you need, for example, IPP client, which is disabled since Fedora 21, you can just enable it to be able to talk to your printers over CAPS. You can also change the zones with command line GUI, dbus, or directly with an RPM file. So if you're providing a zone, just put it into etc firewalld zones, and then you will have it after restarting firewalld. Or reloading firewalld, I'm sorry. As people don't know how to use zones, it's a little bit special. This is something we didn't have before in RHEL 6, for example, or in old Fedora versions. So what I said before, a zone is similar to a complete firewall. And the initial default zone was up to Fedora 20 public. And since Fedora 21, it's different. So on workstation, you have Fedora workstation. On server, you have Fedora server. And on the standard product, or if you're using a minimal installation and are adding your packages afterwards, you will get public as the default. A zone per connection, you only have the choice to have one zone, but a zone can be bound to several connections, interfaces, or source addresses at the same time. But this relation needs to be the word is missing. Okay. You're not allowed to, or you should not. It's not possible to have more zones bound to the same interface, because how should it know what to do with it? Okay, for systems that you that you take with you, for example, a notebook, where you are most likely serve also in other places than in your home or work environment, you should keep a sane default zone. So, for example, right now, Fedora Workstation is not a sane default, because there are lots of open ports you might not expect to be open. The rules in a zone are ordered. So if you're adding, for example, with rich rules, lock, deny, or allow rules, they are ordered right in this order. So at first the lock rules, then the deny rules, and then the allow rules. With IP tables and NF table, with IP tables and NetFilter right now, it's not possible to have a combination of logging and an action in one rule. This will be possible with NF tables, but we cannot use it right now, not yet. Here are examples for zones. The first is the public zone. It's not the Fedora public zone. The Fedora public zone also contains MSDNS. And so here the only defaults are SSH and DHCPv6 client. The next one is a drop zone. It doesn't contain any rule here, but you can add rules here. The default target of the drop zone is drop. So in the end of the rule set or the chain set that is created for a zone, for the drop zone, there will be a drop rule. So for people that are familiar with IP tables, this will be IP tables -j drop. But only for this zone,
What is the default for, if you don't define target?
Then there will be no drop rule or reject rule for the zone, but packets will be rejected then in the final reject rule in firewalld. This is needed because if you add additional rules, for example, with a direct interface, that I will come to that now, you will not be able to have your own rules added, because if you drop or reject before, yeah, nice to have rules that are not usable at all.
So the default is reject.
The zone default is nothing. The zone default is nothing.
Default, but the firewall, the final.
Yeah, it's reject. And we have two separate two different reject types for firewalld, for IPv4 and IPv6. Okay, and the last one is a custom zone. So here you see this zone is bound to the interface EM2. It's bound to the source address 10.0.1.0/24. And it has 3 open services, and it also allows the AH protocol. So the interface and source line in here means the firewalld itself will add EM2 to this zone and also the source address. If you are using Network Manager, for example, and Network Manager is taking care about EM2, then you could run into issues. This is used for, or should be used for, interfaces that are not handled by Network Manager. For example, if you're creating your own interfaces, and if you have disabled in Network Manager that it will take care about the interface or the connection. So the next one is rich rules. Okay, direct configuration will follow afterwards, I think. Rich rules are there because the original service configuration was a little bit limited, but we kept it for compatibility reasons. And with rich rules, it's possible to have much more stuff in there. So, for example, you can bind you can use a source address in a rich rule, also a destination address, and then you can have one element, for example, from service port, protocol, ICMP block, masquerade, and forward port. The same things that we had in the normal service, in the normal zone. And additionally, you can add a limit to all of those. I'm sorry. So, for example, you can say, okay, port 25 is reachable or is blocked most of the time, and you allow maybe 1 per second or 5 per second and so on. Then we have the logging in there, or possible logging in there. This means you can easily say, okay, I want to log everything that passes through. And this can be either done by the normal mechanism in the system or by audit. And also for logging, you can have an additional limitation. So if you get lots of packages on that are passing in through one rule or one rich rule, you might want to limit it. So maybe 1 per hour, 1 per day, or 1 per minute or second. And additionally, you can have an action. So you can say, yeah, we are accepting. In this rule, we are rejecting or we are dropping. And additionally, you can limit here also. So we are dropping every 5th package, for example. Okay, and with the combination of those, you're fairly flexible. We cannot do everything that IPtables is able to do in here, but the most used things. So now we get to examples. Yeah. What is the time? Oh, I think I need to speed up. So you could see later in the slides. I will just skip over it. So we have the direct interface. If you need to add rules that are more capable, or if you need to do things that are not available in firewalld, you're able to do that with the direct interface. This means here you can add your own IPtables, IPsix tables, and EBtables rules in the IPtables, IPsix tables, and EBtables format. and syntax. There are special chains internally for direct rules. These are the direct chains, and they are used before and possibly after you did other things in firewalld or. Additionally to that, we also have pass-through rules. That means firewalld is not taking care about these rules at all. This is for experienced users mostly, and for example, libvirt is using it. Because libvirt is taking care about its rules itself, so adding and removing, so firewalld does not need to do anything with them. libvirt gets informed if there needs to be a recreation of the rules, and that's it. I think I will also skip the examples for direct interface usage because we are running out of time. And maybe, okay, lockdown. This was something we added for L7 to limit access or to limit the modifications. This has been invented. So there is a whitelist for commands, for SLinux context, and for user ID and names, where you can say, okay, this user is allowed to do modifications, or this command is allowed to do modifications, or the command with this as a Linux context, running in this as a Linux context, is allowed to do modifications. This is a very simple version of policies, application user policies. So one plan was to extend this, but it has not been done yet. We have a dbus interface. Every communication with firewalld is going over dbus right now. So even firewall CMD, firewall config, and firewall applet is talking to firewalld over dbus. There you also have the complete interfaces that are available in firewalld. So the runtime and persistent configuration separation. You have zones, services, and ICMP types there. You have the direct interface, and you have lockdown. And for all changes that are done, there are signals. And it's used by all firewall commands and also by other projects. So the new features that we have added lately is policies for server and desktop. This is what I said before. With firewall offline CMD, you are able to change between desktop or server policies. So in server policies, there are bigger limitations. So you need to be authenticated for a lot more things than in the desktop version, where every user can do several things. Then we have Puppet support. So there is a module available in Puppet to configure firewalld. We have added runtime to permanent. This means you can set up your firewall configuration in the runtime environment, and if you like it and if it's working for you, you just hit the key or use file CMD to do the change. So every configuration from runtime will be copied over into the permanent environment. So next time you will get these rules again. Otherwise, if you're doing only runtime changes, they will be lost next time because you didn't do that in the permanent environment. Then we have tracked pass-through. So for runtime to permanent configuration, it was needed to have pass-through in a different way than we had before. So it's now also possible to record pass-through rules. But the old version is still there. So libvirt is still using the old version. But you can now create pass-through rules in runtime and copy over to permanent. It has been done because of the runtime to permanent stuff. And additionally, the dbus interface for the configuration, so a permanent environment, has been extended to match the interface we have in the runtime environment. This way, it's simply possible to do the same things there, and it's not needed to use the Python client class anymore for these things, because before the config interface or the persistent permanent environment was only returning complete zones, services, ICMP types, and so on. And now you can really do fine-grained changes in there. Now we get to the future plans. Okay, something that has been started, or where kind of discussions are came up lately, is a new registration interface in Network Manager. So firewalld will not be called from Network Manager in the future directly. So firewalld will register at Network Manager to get the same information as it got right now, but only registered services will get these notifications. Right now, Network Manager is always trying to reach firewalld, and it's calling a method there, and if it's not available, it just skips over. The next one is Docker, where is a upstream patch already available for Docker to use firewalld, which will solve issues that Docker have right now in several Linux distributions. Because most Linux distributions have a static firewall environment. This means if you're restarting your firewall, yep, the Docker rules are gone. Because Docker is just creating rules when a new container is started, and afterwards, yep, oh, the rules are gone. Oh, my containers are not reachable anymore at all. The next is the integration of IPsec. This has been planned for a long time, but there was no time yet to do that. Then rules for zone interaction. It means, okay, you're using several zones, maybe one for your DM set and one for external and one for internal, and you want to be able to say, yeah, okay, what can pass through from which of the other zones? And additional security environments where you say, okay, here I will allow or disallow special things in my local network. For example, the local address is not allowed to do any external stuff and so on, or not to get in. The next one is direct rules in zones. So right now you have direct rules globally. That means they are done after you did all the other things. So after walking down the zones, direct rules will be honored. And with direct rules in zones, you will be able to have the direct rules in the zones directly. So you can say, okay, if I'm using this zone, I will have these direct rules and otherwise not. The next one is firewall CTL and firewall tree. Firewall CTL will be a new implementation, or is planned to be a new implementation of firewall CMD, where it is using different structures, more in a way like, for example, role CTL, and so on. The next one is NF tables. It reached version 0.4 late, sometime before, and since 0.4, it's possible to do most things that we are doing in firewalld, also in NF tables. But there are still some things that are not working as we need it. So NF table support will still take some time. The next one is to have a transaction set of rules. So you can have not only one direct rule, but several of those, and they will be applied in one transaction. So you can add and remove them easily, and you will get notified if there is an error. So you don't have to do, or if you have, for example, 1,000 rules you want to add, yeah, you're just creating one big transaction, and you're not calling it 1,000 times. The next one is recode and libfirewall. They have been started already, but they are currently on hold for re-evaluation. With some changes that came up lately, for example, with OpenLMI, and also some changes in systemd, networkd, we are reconsidering if a recode is still needed in the current form. Okay. Oh, more information here. We have information on our webpage, firewalld.org, or the Fedora hosted page. Documentation is available in the wiki on Fedora project. There are several man pages for firewalld, for zones, for services, rich language, for the command, and so on. And you can also have a look at the repository. It's hosted at Fedora Hosted. And there's also an IRC channel on Freenode, and also an internal one with the same name. And we have 2 mailing lists for users and developers. Okay, questions and answers. I think we're still already over time, but maybe there are some... 10 minutes? Okay, we have 10 minutes for questions and answers. Yeah?
Can we actually see some examples you skipped?
Yeah, sure. If we have... Which one? The direct or the zone or...
All of them?
Okay. So, rituals. Okay. Here in the first one, you see there's a rule. This is the command as firewall cmd usage in here. So you can add the same string also in over dbus. It will accept it and pre-format internally. So here a rule is added to the internal zone. The service FTP is allowed. It will be locked with a limit of 1 per minute, and it will also be locked over audit and accepted in the end. The next one is IPv4 connections from the 192, 168, and so on address for TFTP. It will be locked 1 per minute using syslock. So here you see --zone internal. So for the internal zone, add rich rule for, we are adding a new rule. A rule starts in the string format every time with rule. The family is here IPv4. The source address is the one we had before. The service with the name TFTP is accepted, and it will be locked with a prefix of TFTP in the info level with a value of 1 per minute. So you will get 1 log line per minute at maximum. So the next one is a little bit more. It allows mute IPv6 connections from an IPv6 address to the radius service. No, it's not allowing, it's rejecting, I'm sorry. It's logging with a rate of 3 per minute. And IPv6 connections from other sources are accepted, and it's saved permanently. Here you see firewall-cmd --permanent. So the rule is added to the permanent environment, not to the runtime as before, as the other ones before. Additionally to the zone internal. And there are 2 rules. The second one is the accept rule, and the first one is the reject rule. And because of the order that we do internally for log, accept, and deny rules, this will work even if you exchange it. This is something that is sometimes a little bit unexpected in IP tables directly, because if you exchange 2 lines, you have to check where you are adding things. And this is something that firewalld is taking care for you, because otherwise it will not have the expected result. So the other one was for direct interface. Here in the first one you see a custom chain named blacklist is created in the raw table for IPv4. So --direct --add chain IPv4 raw and blacklist. And there is a rule to log it, and in the end to drop it. And this is what I said before with IP tables and net filter. Right now, it's not possible to have a combination of a action like drop here and logging or something else. So you can only have one target. So you need to add 2 rules. With NF tables, you can combine them in one, but we're not there yet. NF tables will most likely take 1 or 2 years. Right, Florian? Yeah. Okay. So the next one is add a IPv4 address to the blacklist. You can also use IP sets in the direct interface. Here you don't need to use. Here there is no need to use a internal IP set version, which is not available yet, but I already started it. So the next one is persistent direct configuration. Here you see a configuration file you can create on your own. So it's XML with normal header. It starts with a direct tag. Then there is a chain. It's exactly what you had before, but in the XML version. Then you have the rule. So here you see how it looks like in XML. And then you have the blacklist logging rule, and finally the drop rule. Okay, I think these are the examples I skipped before, right? Or, yeah, we had the zone examples. Okay, so are there any more questions? Yeah?
Sorry, there are any advantages? Because as I see, it's like a lot of XML. Usually tables just only text. What is the main advantage in comparison with IP tables?
Okay, what are the advantages of firewalld compared to IP tables? Okay, as I said before, with IP tables you have to take care about your rules on your own. Also about the ordering of your rules. So if you're adding or removing the wrong rule, it will have unexpected, it will result in unexpected things. And with firewalld you have a deepest interface. So you can use it from other applications directly, and you can limit it. So with IP tables, you have more features in IP tables itself, but with a direct interface you can use them in firewalld. And for example, if you're using permanent direct rules, you will have a similar experience that you had before with the IP table services and IPv6 table services, which is still also another thing. With IP tables and IPv6 tables, you had 2 services. And with EP tables, you had an additional service. And here, everything is combined in one place. So it's doing all the things for you with starting, stopping, and so on in one place. Yeah?
You do invoke the IP tables in the IP tables columns, right? You don't speak to the kernel directly.
No, we're using IP tables, IPv6 tables, and EP tables internally.
We call them that.
Yeah, we are calling them. There is no other way right now.
If you store a lot of rules in one go, what do you do?
Right now we are doing one rule per time. So one after the other to make sure that...
For each rule.
Yeah. And with the transaction sets, you will get more.
What about order? I want to drop for someone connection, but also for another. In this case, order of rules
Does matter, yeah. With direct rules in zones, this will be done automatically for you. You can then, for example, say, okay, these are the direct rules in here. They is specific to this rule, to this zone, and the other ones are not affected. So you can also simply change between the two. And this is also something that is not available, not possible with IP tables itself. We have zones, so you can say, okay, this connection is right now in this zone. I want to switch over to another one. So, just switch over and it's done internally for you. And with IP tables, you would need to remove rules and add rules. Okay? Oh, I see we are out of time. So, if you have further questions, please come to me. I will answer them for you. Thank you. Nice. override rules for outgoing traffic? You can with direct interface. We're not doing that in firewalld for zones right now, but you can do that with direct interface. But this is something that will also come with the security environments for zones, where you can say, okay, I want to have a limitation here.
Which kind of limitation?
For example, against spoofing and so on. So there are some things planned already, but they're not available yet.
So only incoming traffic can.
Yeah, with zones right now, yes, but with the direct interface, you can also add rules to it.
Okay, and if I change IP tables rules directly from command line, can firewall be detected?
No, it's not possible because of limitations in NetFilter. NetFilter is not able to provide information or to notify. There is a change. It's not possible. This is something we could get with NF tables. There is a monitor feature, so we can monitor what is going on there, so we can see the changes there. But it's just adding the thing, or it's just outputting the command you added. So we have to parse it again.
But in case of imagine the following scenario: I change the rule manually. After that, maybe some servers change firewall D. And what firewall D make in this situation? Because original chains in IP tables corrupted, and firewall D needs to recreate all chains.
And cannot detect it without polling. Without active polling, it is not possible. Therefore, we are not doing that right now.
It cannot be active polling, but when firewall D adds some,
it prints out a message.
We can poll it before we add rule. To understand, of course, in some race condition, I can understand that okay, it's okay, let's add rule, but in this case, we can save ourselves by check integration twice before adding the rule and after adding the rule.
Yeah, but we need to be able to parse complete IP tables.
Okay, it's value, I think, because it's great value. Now you just implement more complex language